Thank you very much, Alex, for the introduction. And so, as you said, hello, my name is Joana Pinto, and today I will be talking about the use of spray congealing and wet sieving as alternative process for the engineering of D-mannitol carriers. The aim of this work was to develop new carriers particles that were able to improve the aerosolization of dry powder inhalers. Usually, alpha lactose monohydrate are particles that are used as carriers in dry powder inhalation. However, these present complex polymorphism and also degrade upon melt, which limits their processability. D-mannitol, another sugar that does not have these limitations, was then chosen as an alternative sugar to be processed as a potential carrier for DPIs. As such, in our approach, we started with a non-inhalable grade of mannitol. And for the wet sieving process, we put this in a tower of sieves that was vibrating, and we washed it with acetone. And for the spray congealing, we melted our mannitol and then sprayed it into a chill tower, and then collected the solidified particles into an outlet vessel. All the powders that we produced were then characterized concerning their solid state and surface topography, size, and flowability. And for the aerodynamic performance, we have blended these powders with a model API, beclomethazone dipropionate, and we have tested their aerodynamic performance by the shot weight uniformity and NGI. So after wet sieving, we saw that actually the polymorph was the same as the raw material, which was the beta mannitol. For the mean particle size, we also saw no change. However, we did see a drastic decrease of the fines from 2% to 0.45%. The shape of our carriers also did not change. However, the surface topography did change dramatically, and we saw that after washing out the fines, we actually had particles with deep voids and clefts. The flowability also didn't change, and as the raw material, we had cohesive carriers. For the spray congealed material, we saw that we had a change in the polymorphic state, and we saw that we had alpha mannitol with traces of the delta form. For the particle size, we saw a decrease, and we saw that we had a mean particle size of about 100 micrometers. For the percentage of fines, this was identical to the raw material, which is about 2% of fines. The shape of our carriers did change also dramatically, and we saw that after spray congealing, we had spherical carriers with a very smooth surface. And this led to actually an improvement of the flowability, and our powders were free flowing. Concerning the aerodynamic performance, our key findings was that after blends with BDP, our spray congealed materials actually led for a higher mean mass of powder being dosed per shot. For the wet sieve materials in blends with BDP, these showed a lower inter-device variability when compared to the raw material. However, the addition of fines of magnesium stearate and pre-blend did not show any benefits in terms of improving the device variability. For the fine particle fraction, we have seen that compared to our other materials, our spray congealed carriers were able to lead to a higher fine particle mass and fraction of BDP in binary blends with the API. For our wet sieved carriers, we actually saw that compared to the raw material, we did saw a slightly lower fine particle fraction of the API. However, when we added fines of magnesium stearate and pre-blend, we saw that we were able to improve our aerodynamic performance, and actually the highest FPF of BDP was seen when the wet sieved mannitol was used in ternary blends with the use of pre-blend fines. So our main conclusions was that wet sieving was appropriate when we want to control better the number of fines of the formulation, while spray congealing has the potential to generate spherical smooth carrier particles. As for the addition of fines, this was only beneficial when we had very rough particles, such as the one produced via wet sieving. For the spray congealed carriers, these were able to improve our aerodynamic performance in binary blends with the API, which proved to be of great advantage. If you want to know more about our work, you can see our publication in Pharmaceutical Research and also our patent on novel carriers produced via spray-congealing. Lastly, I would like to thank the COMET program in Austria for funding this work, as well as all my co-authors and you today. Many thanks for your attention. Thank you.
Thank you very much, Joana. Nice, very nice. A couple of questions for you. To start, you're using mannitol as a proposed carrier as an alternative to lactose. But what's the implications of those different forms of mannitol, the alpha, beta, and the small amount of delta?
Yeah, so the alpha and beta actually they are monotropes, and actually their free energy of Gibbs is very similar. So actually that's not a large problem because the alpha polymorph is quite stable, such as the beta. So that was not a concern. What was of concern to us was actually the traces of delta mannitol, which were actually metastable. And for that, actually, before the aerodynamic performance, this is more explained in the paper if you want to know a little bit more. But before the aerodynamic performance, we actually have preconditioned our powders in a desiccator at high humidities, and we were able to actually transform all the delta mannitol in beta. And we have seen that we didn't have any alterations in terms of our particles after this, because this was just done overnight. And like that, we were able to get rid of the metastable form without impacting the performance of our carriers.
And a comment from the audience that they're clearer on the benefit of the wet congealed, the spray congealed processing. But the wet sieving, where you then add the fines back, what's the advantage of that particular process?
So what we have seen is actually once we take out the fines that come with the raw material from the primary manufacturing, we actually saw when we added fines in a more systematic way and in a more controlled way, we actually had a benefit in terms of the aerodynamic performance, meaning that we were able like this to improve the fine particle fraction in relation to the raw material where you don't do anything. So this was the main advantage in that case. However, I would say that it depends a little bit on the case, because here we actually also had to add a large amount of fines, which sometimes with certain inhalers or inhaler devices can also be a challenge. So, yeah.
And a couple of questions on technical questions. Did you look at blend homogeneity?
Yes. We did look at the blend on homogeneity, and they were all below 7% relative standard deviation. So we have considered that all the blends were homogeneous.
Mm-hmm. And did you look at any quantitative measure of the smoothness of the particles?
Yes, we actually, this is not published, but internally we did do. From the SEM images, we tried with the software to actually quantify the roughness. We did quantify this roughness in qualitative or pixel terms. And we have actually also calculated the bulk roughness, which is something that is sometimes described in certain papers. And we have seen actually in our paper, you can also see presented the bulk roughness. And we have seen that, for example, for once we take out the fines, you really see an increase on the roughness. This can really be seen in the SEM images, in then the treatment of the SEM images, and also in theoretical calculations with the bulk roughness.
Thank you. And a final question. You did your work with beclomethasone dipropionate. Do you have any additional experience, say how generalizable those findings are to other BPIs?
Yes. So for our patent, we have actually tested 2 additional APIs with different log Ps. We actually, with a very smooth carriers that we have in the spray congealing, we actually saw that, for example, one API that had a very high log P, we saw that, for example, with low shear blending, we were not able to get homogeneous mixtures, and we had to actually to use high shear. But once we used high shear, we were able to obtain homogeneous blends. So here we did saw that with very smooth particles might be a challenge sometimes to get them attached and to have an uniform mixture. But once you go to high shear, that that problem can be overcome.
Okay, thank you very much for answering all the questions, and we'll move on in the interest of time. Thank you.
Thank you.
Thank you.